Hello and welcome to Micro Minute. My name's Marty Jobson and today we're part of the Global Science Show. And what I'm going to show you is some cross-polarized light microscopy, which is all a bit of a mouthful. So the first thing we're going to have to do is, I'm afraid, I'm going to have to start with some basic physics, but trust me, this isn't so bad as it sounds. Okay, we've got light as a wave. Light you can think of as a wave, but the light that comes to you from the sun or from a light bulb isn't just sort of a wave like that. You've got a wave like this and a wave like this. It can come to you at any angle, okay? And a polarizing filter is basically just a grid like this that allows light to pass through it, but only if it's going up and down in the same direction as the bars on the grid go. So light goes through like that, but if light is coming through at an angle like this, it doesn't go through, it gets stuck. And some light goes through, but not all of it. And they use this in sunglasses quite often because it lets some through, but not all. Now, what we've got is we've actually got not one polarizing filter, but two polarizing filters. And the second polarizing filter is at a different angle. It's at 90 degrees to the first one. So the light goes through the first one, like that. And then the light hits the second grid. Where's my grid? There it is. And it doesn't go through. So no light goes through, so it appears black. And you might be thinking, well, that's completely useless. Why would you want to do that? Well, that's where crystals come into play. So, okay, here's my microscope. Let me explain to you the setup on the microscope. I'll show you if I do this. I'll put myself in the top corner there like that. So I'm still here, and here's the microscope. Now, this is the light source. Underneath here, I have a filter which sits on there, and that is a piece of polarizing material. So the light that's coming through there is only in, he says checking, it's coming through, and it's coming through only like this, okay? So it's sort of like going in that direction and not in that direction. And then at the top here, there's a second polarizing filter. And at the moment, the two polarizing filters are lined up. So the light goes through the first one, and then it goes straight through the second one. So if I show you what you see down the microscope, by turning that off, you can see white. The light goes all the way through and you can see the light. But if I rotate this top filter here, because it's almost sort of a little clever swizzly thing, if I turn it slowly, 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 it gradually gets darker and darker and darker and darker and darker and darker until suddenly it goes completely black. And at this point, the two polarizing filters, one of them's like this, and one of them's like this, so no light gets through. And if I twist it again, the light comes back. But what we want is we want it at right angles, so it's completely black. And I'll get that lined up just perfectly, because now what I'm going to do, I'll go back to this, is I'm going to take a slide that I prepared earlier that I've allowed some crystals to grow on it, and this is citric acid. So it's just stuff you can buy in a chemist. And these crystals, you can see they're sort of slightly white, but they're basically translucent. Light passes through them. And when I put them under the microscope, look what happens. Suddenly, oh, you can't because I haven't put the microscope on. There you go. This is what happens. You get these amazing patterns. You can see the crystals, but more importantly, they suddenly show up these amazing multicolours. Let's have a little look around at what we've got. So let's zoom in on this little section up here and focus. And what I'm going to do is I'm manually doing the exposure, because I get better results if I do this manually rather than using the auto exposure, which tends to get its knickers slightly in a twist. And look at that, isn't that amazing? Look at those beautiful colours that we get. And all because, and if I take it out, if I slide this out, it's completely black. Put it back and you get these amazing colours. Because what's happening is, as that bit of my wave, my polarised light is going through the crystal gives it a bit of a twist. And that's why we can see this. And different wavelengths of light, different colours of light, twist a different amount. Now, there's another section. Where's a good section? There's a bit here. Sorry, that's my phone bingly beeping. I should have turned the sound off. Here's a good bit here. This is rather fun. I'm going to turn that off because I'm getting Twitter messages. Here's a beautiful section. Look at that. Isn't that amazing? And if I rotate the polarized filter at the top, you'll see the light gradually, the colors disappear completely. There, they've gone completely just about. And then I go back. And the thing is as well, depending on where the angle is, it all depends on the structure of the crystal. Because look at this bit here compared to the bit here. So when this is at its most colourful, sort of about there, this is completely black. And then I rotate a little bit more and it starts to get colourful, and I go that way and the colours change. And even if I rotate the actual specimen itself, well, that's actually rather difficult. If you turn the specimen, the whole thing changes as well. Okay, right, well that's just one type of crystal I've shown you. Now I was growing some more of these, so citric acid, I grew some more here. Look, this is how I grew these ones. If I turn my desk camera on again, I'm trying a different method. I drew some little squares on a cover slip with a special pen that marks glass, and then I put some citric acid in water on there and allowed that to begin to crystallize. And let me get this way around. And here, look, you can see it's a bit overexposed now. I'll just go back in and change the exposure. So what you've got here is the little square I drew, and then it's under my head. Just there, just there is actually an undissolved crystal of citric acid that was just sitting on top of the slide. And from that grew all these crystals. And I actually watched these grow as I was sat here. They've finished growing now, but there's another one over here which is rather lovely. Look at that. Isn't that good? You can crystallize different things. Here's a different type of crystal. This one is aspirin in ethanol. Aspirin dissolves actually quite well in ethanol. So this one works quite well. And here it is. Look at that. And it creates a completely different type of crystal. It's not quite so colourful, but it's still quite good fun. You get these sort of little rosettes forming instead. And if I zoom in, there are some colourful patches. Like there's a little nice colourful patch just there. Look at that. Sort of almost like a Milky Way going across. And again, I'll just do the colour balance a little bit. There we go. And you get these amazing crystals, or really tiny, tiny ones there. Focus. And then really massive, mahoosive, big crystals there. Incredibly beautiful. But what I'm going to do is I'm going to go back to, this is another citric acid crystal that I was growing. And this one, oh blimey, this one has grown. It's grown massively since I last looked at it. When I looked at it earlier today, it was just a few little bits. And this one has grown these cool sort of needles almost out like that. Now, none of this is possible. I can't do this without the help of the lovely people at Zeiss who give me these microscopes and say, fly, go show people microscopy and do wonderful things with it. Microminute is a thing that happens every Mondays, Wednesdays and Fridays at 12:30 British Summer Time here on Twitter, and I'll move it and it moves up onto YouTube. There's a whole load of videos you can look at, all sorts of things I've looked at, biological, botanical, materials, things, all sorts. Check it out. Thank you very much for tuning in. Hope you enjoy the rest of the Global Science Show. Up next is, I wrote it down, Kirsty Ross in Glasgow. So over to you, Kirsty. Thank you very much. My name is Marty Jobson, and this was Microminute.